So I thought I'd show you what I do with most of my time. These two little boards here are what you call development boards. This here is probably one of the most popular ones. It's called the Arduino Uno. So the Arduino is the product or the company name. This particular board is a Uno, and this comes from Texas Instruments, and it's called the Launchpad. What both of these boards do is allow me to program a single microprocessor or a microchip. Excuse me. Now what this is good for is prototyping, experimenting, and developing any product that needs some form of interaction with the environment, so or communication, so maybe pressing a button or a thermometer or a hydrometer, light sensor, a motor or some type of switch. There's a myriad of variables there, but you're looking at basically a way to develop an idea of, I need a very small computer or a small program that can interact with the external environment. So in both of these cases, with the Arduino, you've got these headers, female headers, and with the Texas Instrument one, you've got both male and female header connection pins. And these basically, as I said, what allow me to do is to connect anything like a switch or a light, an LED, temperature sensors. I can even put an LCD screen onto these, and I can communicate with those through the board very easily by plugging this into a computer through the USB ports, and then using a small program which then allows me to program these chips and interact with the different circuitry that's on the board. So that's the beauty of them. The slightly difficult part is because these chips have a very small memory. This one only has 256 kilobytes. Yes, I said kilobytes, not megabytes, kilobytes. So you've got to be careful with your coding. But it also means that the way you code is you speak closer to computer language than you do human language. So with major computers and even things like a mobile phone, those type of things, what you find is you have an interpreter between the human that's using it and the computer itself. So if I press the number 2 on a mobile phone, that's my human interaction. I want 2 to show up on my screen or to be dialed by my phone. There's then an interpreter, a middleman, that interprets my actions and translates that into computer language, and then tells the onboard computer what to do. The computer goes, oh, okay, I understand, and then it sends it back in a format then the human can then understand, and being that I would then see the number 2 on my screen or hear it being dialed on the phone. That interface or that interpreter, things like the Windows operating system and the Android operating system on a phone, they're basically they're called GUIs, which is a graphical user interface, and that's the interpreter between what the human wants and interprets that into a language that the computer understands. With these small boards, there's not enough memory to actually hold a large operating system to make it easy for me to tell the computer what I want. So what I have to learn, or what you do with these in these circumstances, is you speak closer to computer code, computer language, than you do to human language. So the coding you have to learn, and the interaction between these boards is not as friendly as, let's say, a mobile phone or a computer operating system, but it means then that you can I don't need to go to a large computer just to make something that turns a light on and off, which would be a waste of resources, really. But for someone who doesn't understand those languages, yes, you could do that. You could use a whole computer to then tell it to turn your lights on and off at a particular time. But this actual microchip could do exactly that same process if I can get the language on there to tell it what to do. So these are a good starting point for basic development. Then when you've got your particular idea, you can then even go down to smaller products like this little teensy here. Again, this still has a USB interaction. As you can see, there's a lot less componentry on this than something like the Uno, simply because after you've worked out what you really want, and you probably don't need all these type of things and the buttons and the switches and all that sort of stuff, so you then translate that onto a smaller board. This microchip basically holds the same sort of amount of information, but it then reduces it down into a tiny small package, which is then more user friendly to put into your final product, let's say. So then this one, you can probably see there if I line it up. Yep. So this one here, it shows you what all of these are basically soldering points, so I can stick wires or header pins in there and then attach different things, exactly the same like that big board, but we've gone down a size. Something again similar, this is another brand, it's the Huzzah Feather, and this one actually has Wi-Fi. That's a Wi-Fi aerial. So again, we're looking at a small board, but that can actually interact with your network itself. So you know, if you dropped your phone and the back of your phone broke open, you would actually see something similar to this on one of the boards that's inside your phone. So if you think of it in that way, this is a small part of a phone that I can then tell it to do something. So because it has Wi-Fi, I can instruct this board to interact with the internet. I can tell it to do something on the internet. So a small board like this, you could program to check the internet once an hour, and find out what the weather's like, and then let's say it goes over a certain temperature, you then tell this to turn on a switch that turns your air conditioner on or off, or your heater on or off, or things like that. We call this type of development the IoT, Internet of Things, and that's where you have small boards, development boards like this, which are then interacting with the internet and also the real world itself. So our houses and our homes are becoming a lot smarter over time, and these are the type of products that you can use to develop those ideas. The final two that I can show you is this one here, the AT-Tiny, which this is the one I first started with, and it simply plugs, that there is a USB port, it simply plugs directly into a USB port. It's got a very small amount of memory and a very small amount of user inputs and outputs, but it is still a great little unit. Like, you can cover this in resin, and I mean, originally I actually had one of these which I just plugged into my standard USB, and I wrote a program on here which, when I plugged it into my computer, actually on my tablet, because my tablet, I really don't like the screen and typing stuff. So when I originally turned my tablet on and it asked me for my password, I just simply plug that in, and this little board I programmed to type out my password, and then automatically it hits the enter button. So it types the password, hits the enter button, and then that automatically logs me into the computer. And that's a very simple thing, but again, you could put a temperature sensor on this and a relay switch, and write a program to say, okay, when the temperature goes above certain degrees, turn an aircon on and then turn it off, or when it goes below a certain degree, or sound alarms. These are good little units, and at that stage you then don't need the USB port. This is beautiful because it does have USB interactivity. When you plug it into a computer, the computer actually recognizes it as a USB device. But once you've programmed the unit and you forget about that, you can then just have this board powered and whatever's programmed on there, when the power's on, it'll just continually loop through and do whatever that does. So it could count how many times somebody walks through a door. It could sound an alarm every hour. It could do all sorts of very small. It's a small programmable board, but again, really tiny. I love these type of things. And then the last one, this isn't the actual model I'm using, but my pinky stick build, so my prototype that I've been developing for the last year now, is based on this board. This is a Chinese clone of what's called a SparkFun Pro Micro. So if you take a look at the Arduino board again, and then shrink this down, it uses the same Arduino code, the IDE, so I can use the same sort of interface to communicate. It again has a USB port, so it plugs directly into the computer, so I can then program this chip. But the product that this is the development board that I'm using to basically program this chip, which is what I use. This chip is the main guts of what I'm using for my invention. So that's development boards. Now, as I said, with development boards, they're simply a small board. They don't have an operating system on them, so they don't have anything like a Windows operating system or an Apple operating system or Android phone or Linux or anything like that. There's no user interface as such. The USB port is specifically there to transfer your program on and off the board. That's its main purpose, as well as powering the board itself. But once the program is then onto these boards, any of these boards, what happens then is, as I said, if it's powered, it just runs the same program over and over. It does what it's supposed to do. So that's then when the automated factor comes in, where you can have these things doing specific tasks, and they will just just repeat those tasks over and over until eternity, or until the power goes off, or until you turn it off and then on again. So that's development boards. Next, I'll show you my SBCs. Stay tuned.